Hello, good morning. I hope you all had a good breakfast and you're having a great conference. So we'll briefly introduce ourselves. We're going to talk about breaking into managed data services. So my name is Yoav, and I'm the CTO at Orca Security, and I've been a security researcher for the past 15 years.
My name is Tzah. I'm a security researcher at Orca Security, and I'm doing security for around 6 years. And would also like to mention Yanir was a key security researcher in the research we're going to present, and he couldn't join us today. We'd like to start our lecture with a history lesson, a quick history lesson. If we're talking about severe cloud vulnerabilities by year, and I'm talking about high and critical severity vulnerabilities affecting millions and millions of customers, the year of 2020 had 4 of these, and this data is based on cloudvulndb.org. And if we're going at over 2021, we have double that, we have 8 vulnerabilities. And 2022, 14 cloud vulnerabilities, each affecting millions and millions of companies. One reason why this incline or this rise was so dramatic, we're going to figure out by the end of this presentation. So what are we going to talk about today? First of all, we're going to introduce some of you who may be less familiar to the cloud and to the key security concepts. Then we're going to define what are managed data services. We're going to show you how we hacked some of these with video demonstrations, show you the recipe we have for cross-tenant vulnerabilities, hacking managed data services, and conclusions. But first, we do need to become cloud experts. And we only have 5 minutes for the intro. This isn't happening. But we do need to understand the basics. So the most important thing to understand about the cloud, I would say, is there is no cloud. There's no such thing. The cloud provider has their own setups and data centers and computers, and they write their own software to provide the services I need as a customer. It's not magic, it's software. And as every software, it has potential flaws and bugs. But what cloud are we talking about? We're not talking just about the internet, we're talking about specific cloud providers, the major ones that your company probably is using, AWS, Azure, Google Cloud, etc. And we want to talk about why these, as an introduction, why these even exist. What problem does the cloud even intend to solve? So let's say I want to build an AI application. I want to build an AI application for pets. That's my goal. That's my life mission. Call it ChatGPT. Now what do I need to do, right? I need to have storage, I need to have networking and high uptime, and I want to have the best security probably, right? So basically what I need to do before even starting to program, I need to build a data center myself. But me, I just have a dream. ChatGPT, I want to talk to cats, and I can't do this right now because I need to build all this data center. So the benefits of the cloud, it lets you focus on what you need to focus. If I want to develop my app, I can write the logic and I can deploy it, and it will just work. And 3 main benefits are the cloud is scalable, meaning if I'm talking about a virtual machine, for example, I can start 1 and I can start 1,000 in a second. It's cost effective, meaning I don't pay upfront for the hardware and the equipment I'm using. I only pay for as much as I use as I go. And the third thing is it's reliable. It has high uptime, it has backup, so even if a data center goes on fire, there's another backup for my app. And it has good security. The cloud itself, one thing is also important to understand, the cloud itself is built on services. What usually would happen is me, as a customer, would go from my account, say to AWS, and would make an API call. A signed API call. The signed meaning it's authorized as my account. And then I could access any service I want. EC2 is the virtual machine service, the bucket is S3, which is the storage service, and then I could use them. Let's say occasionally, I would want to use a more complex service, say CloudFormation. It's not very important to understand exactly what CloudFormation does, but I will say it takes template files and it deploys them as resources in your account. So it could have a file mentioning, hey, please start 5 virtual machines, and it will start 5 virtual machines. So when I make an API call to AWS. AWS will tell CloudFormation, okay, go fetch that template from S3 or go deploy this in EC2. CloudFormation would also need to use cloud services. So CloudFormation itself would make an API call to AWS and ask to use EC2 and S3, etc. What this means is CloudFormation and some services in AWS, I would say most of them, have cloud accounts themselves. The same way I have an AWS account, so does CloudFormation internally have a normal AWS account. If I could access that account, this would probably be very, very interesting. But to normal customers, this isn't very interesting, right? This is for the researcher mind. The customer's responsibility when you're talking about security and what the customer needs to worry about, there is a security model called the shared responsibility model. In this model, it says everything that the cloud customer can configure, it's his responsibility to make sure it's secure. Take a virtual machine, operating system and up, the files, the permissions, the passwords, making sure they're secure. Everything revolving that is the customer responsibility. But everything that the customer cannot control, for example, the low-level networking, the hardware, the building where the data center is stored so no one breaks into the building physically, that's the cloud provider responsibility. Most of the research in the world today is done around where the customer can misconfigure things, which is interesting, but only affects a handful of customers. We rather focus on where the cloud provider fails. And when you find the flaw in the cloud provider, it affects every single customer of that cloud provider, especially using the service that you target. Now, the key principle to understand this entire presentation would be the key security principle of the cloud. Tenant isolation. What is a tenant? Let's say every company is a tenant. Orca Security is a tenant. Your company in the cloud probably has their own tenant and maybe even a few. In AWS, it will be an account. In Azure, it will be called tenants. In Google Cloud, it might be projects. Doesn't matter the name. The key idea is tenant isolation, meaning a user from company A would only be able to access whatever he has permissions into, but only in company A. The scenario we would like to trigger is what happens if user A from company A will be able to access company B. This will be called a cross-tenant vulnerability. And this is, as a researchers, our holy grail and the cloud provider's biggest nightmare. Our goal in finding these is, first of all, to secure the public cloud, because we're good people. We want to make sure the cloud is safe to use. We want to discover a method and a pattern to find these again and again so we can still report them to the cloud provider, fix it, and make the cloud more secure. But let's be serious. The really big reason that we want to find these vulnerabilities is to lecture at Black Hat Asia. So why is this interesting, right? Let's wear the black hat for a second. Millions of companies and their data stored in the cloud. You can also infiltrate other companies' networks, which are also, at part at least, in the cloud. And if we take over a service, we have infinite harm and data potential that we can do. So it is very interesting. But why is it hard? We talked about tenant separation, tenant isolation. This is the cloud's main security promise. They say, move to the cloud, it's more comfortable, it's more secure. Move to the cloud, share resources with other people, but your data will stay private. If we can prove or we can show that your data would not stay private and you're actually risking yourself, that's a very big problem for the cloud provider. And it's also very hard because they have a huge attack surface, most of it without source code. In Azure and AWS, they have over 200 fully featured services. But to start our story and to show you how we found the pattern and how we hacked cloud services, we only need to hack one of these. And this led us to all of this pattern and the methodology. I'll let Yoav take you through the first vulnerability.
Thank you, Tzah. So I'll take you for the first vulnerability, which is called superglue. It was the first ever public AWS service takeover. But this is the end. We'll start from the beginning. where we did entirely different research. When I say we did, I mean Tzah did. He basically started investigating the serialization mechanism in AWS. And he started getting error messages in Java that hinted to us that there are jar files corresponding with those errors. So we did what every good researcher does, which is we took the jar file names that we found and we searched on Google. And to our surprise, we usually get no hits. We got a hit. And those hits led us to believe that the jar files we were looking for are found in a service called AWS Glue. So for those of you who don't know AWS Glue, that's okay. He is not one of the most famous services. But it's a serverless data integration platform, which basically means that you can take data, usually from S3 or other data sources, run jobs, which basically take the data, transform it in some way using what they call a job script or a transform script, and put the data in somewhere else. This is called ETL. And the most important thing to remember here is that the transform scripts are run serverlessly. Serverless usually means someone else's computer, again. So the first thing we want to do is try to run scripts there. And when you try to run scripts, they send you to the development endpoint, which is basically a machine that you can SSH into and to test your scripts. It's a developer feature. The first thing that we did, we SSH'd into the machine, but we tried to see where the EC2 is running from, because we ran the describe instances, which lists all the instances in the account, and basically the instances were not there. So we concluded, or we hope, that this instance that we have an SSH to is not in our account. If you are ever, this is a pro tip, if you are ever dropped into a shell on a cloud instance, the first thing you try to ping is the instance metadata service, which is basically a magic HTTP server running on your VM that is always accessible on on IP 169.254, 169.254, and you get a metadata about your instance, which basically it's really useful for IT. Think about it, if you're running a generic script and you want to fill the gaps. But it's also used by all cloud providers to provide credentials into the system. So for example, you don't want to upload keys into instances, you want to associate permissions with your resource. That's the way the credentials get into the machine. So we did what we talked about. We tried to access the MDS server, and what we expected to get was the response on the left, but what we got is this thing, which is really weird. And we understood that this is basically, it's a trap. No, it's not a trap, but probably a fake local server, which is supposed to not give us the right response. Probably using IP tables to block us and route us to a different server. So what we did, we tried to flush the tables, but we didn't have any root access on the machine. So we tried to privilege escalate. We used sudo -l to list all the binaries that we can run as root. And we found that there was one binary that's called update spark defaults, which is a Python script. And we get the keep-env directive. Keep-env, for those of you who don't know, allows me to inject environment variables to sudo binaries. Python path controls where Python loads its module. So I can run a Python script and tell it where to load its module. 1 + 1 equals privilege escalation. And in that case, we just created a module called stat, we ran the script, and we got root. Nothing surprising here. The next phase is we want to go ahead and flush the IP tables. Flush the IP tables, and we got to the real IMDS servers, which is really cool, and it confirmed our suspicion. We're running not within our accounts. This dev endpoint is running in a cloud provider managed account. But also, we were able to get cloud credentials. Those credentials were belonging to the cloud account, belonging to the Glue service. We were really excited at this point, and we did what every good hacker does. We enumerated privileges, we ran it, we ran it, we ran it, and we got nothing. So, yeah. But if you remember, we were looking for jar files. This was like a side quest. We were just trying to find the jar files to advance our research. So we researched the system, we couldn't find jar files, and then we decided to run the Glue script on the serverless engine to see if we can find jar files there. We listed all the files in the system, and we were expecting to get the jar files. To our surprise, we didn't get one jar files. We got a lot of jar files. It was like jars everywhere, and we started looking through the jar files, and we found they were referencing. Some of them were public, known jars, but some of them references internal AWS services, and one of those was called Glue.js. Glue.js is a job executor service. It's an internal service. We couldn't find any public documentation about it. And we tried to talk to the API. The SDK, the internal jar files basically had SDKs calling to an internal API. So we tried to call this get EMR credentials, which is one of the internal APIs, and we kept getting access denied. No matter which privileges we gave the principal, we couldn't get it to work. But at some point, we said, wait, we have those internal credentials with no permissions. Let's try this. And instead of getting access denied, we got wrong EC2 instance, which is not access denied, which is better, but it basically means we were passing the wrong parameters, but we basically bypassed the permission check, which got us a bit excited. So we kept digging around, and we found a Smithy schema. For those of you who don't know, AWS has an internal language to describe all their APIs, and it's called Smithy. And it's it's an open source project. You can look at it, and all the public SDKs are generated from it. But we found Smithy schema also for the code that we found that was generated, but also for APIs that were not listed in the SDK at all. And one of them was the Get Jobs API. When we ran the Get Jobs API, we got a job that was running in the internal account. So I want to to focus your attention on two things about this job. We got one job back. One is the script location, which is basically on S3, and the other one is a role. Basically, if we can, the jobs are running from that script and running with that role. So we said, okay, we can list the jobs, but can we create a job? So we found that there is an API for that called create job, which receives a path to S3 and an IAM role to assume. So we created a bucket, we uploaded the script, we created a job, and we got a reverse shell. At this point, we were really, really, really excited. So we went ahead and enumerated permissions. We enumerated permissions, and we rated, and we waited, and we got nothing. At this point, it's important to note, if you haven't heard from the accent, that we're Israelis. And this means that we don't have an AWS region close to home. So we usually use one of the European data centers, which are closest by distance. And one of the things that we discovered looking through the internal jars is that AWS regions, for example, if you use like the Glue service in some region, it's going to one account. And if you're going to a different region, it goes to a different account. Each region is actually hosted in a different AWS account. They use it to separate to make sure that if one account goes down, not all the regions go down. So each account basically has a different account number. So we figured, wait, maybe different accounts are managed by different DevOps team. Maybe they have different jobs. So we decided to brute force all the regions, and the first one is USD Swan. And we used USD Swan, and instead of getting one job, we got like hundreds of jobs. And one of them had a really cool role called AWS Glue Service Role Default. Sounds really promising. It has a default name. And we did the same thing. We created a job, we uploaded the script, we ran the reverse shell. But this time, we had an administrator access privileges on this account. Not just any account, but the Glue service account. So we basically have an admin credentials in the account that the Glue service runs from, which is insane. So what can we do with this administrator access for the whole Glue service account? So the first thing is that we can use the trust that the Glue service has for all other AWS customers. So for example, if you have a policy that trusts the Glue account, uses the Glue Amazon AWS, we were able to assume to that role. We were basically able to access your account on the behalf of the Glue account. And while we were accessing your account on behalf of Glue, we could also access your data. So I'll go with a quick video demo to show you what we did. So the first thing is the exploit which I discovered. Now we are running as the Glue service. At this point, you can see that we have a full admin on the Glue service account. And we are switching to a victim account where we have a default role that has a trust to the Glue service, meaning only the Glue service can access this role. We are trying to assume this role, and we successfully done so. And now we will try to use this role to access the victim's data. In that case, so we see there's a bucket called MySecretData, always a good bucket name to have. And it has the data file in it. And since this is recorded, I can tell you it's going to work. And we got data from different accounts. So I'll do a quick recap because we talked about a lot of things here. But the first thing is we started from our tenant. We went and we got an RCE, which was basically a feature using the SSH to a shared restricted runtime. From that point, we were able to privilege escalate and get a role in a restricted account. And from there, we were able to research the internal API and get access to the internal service, which allowed us to get a role and assume to other tenants. So basically this entire thing is a pattern, and we see it again and again. We call this pattern managed data services, and it has a few characteristics. The first one is that the service usually involves data ingestion, import processes of user data. The workload is serverless or managed by or a compute that is not under our tenant. And sometimes, as a bonus, the compute is even shared between tenants. All of these characteristics are the criteria that we use to search for new services to research. And I'll pass it back to Tzah to talk about more instances of this issue and how we found our next vulnerability.
Thank you. So we did find a pattern, and we did find characteristics for services that might be vulnerable to this pattern. We call them managed data services. And the pattern was this, again, the tenant, you do an RC on a shared restricted runtime, you make it less restricted by privilege escalation, and then with internal API, you could probably access other tenants. This was our assumption. And the first step, if we want to apply this pattern in another service or another cloud provider, would be finding the shared restricted runtime. We need to find a runtime that is not under our tenant and that is a feature by a service. We tried to look for the same pattern in Azure, and this led to this. Synapse. It's a service takeover in Azure Synapse. The service is called Azure Synapse Analytics. It is an ETL service. ETL means extract, transform, and load. It takes data from wherever you want. It has over 90 plus services you can import data from. Then you can use SQL, Apache Spark. You could use many programming languages to process the data, and you can output it into Azure in whatever format you'd like. And if you remember the definition of a managed data service, the first thing is data ingestion, meaning it either imports, processes, and exports user data. We have all of them. I say check. How do you import data? There's a feature called linked services. You just go to the user interface, you can click on you have 90 plus, again, services that you can connect to. Let's say MySQL server. You put the IP of the server, you put the port it's running on, and you put the credentials. User and password. Makes sense. And then you can import the table from your MySQL server into Azure Synapse Analytics. One thing you also need to do is to choose an integration runtime. There's a default one called Auto-Resolve Integration Runtime, and then you can also create some of yours. What are these integration runtimes? Compute infrastructure used by Azure Synapse and Azure Data Factory, which is another service. And they have two types, either Azure Integration Runtime or a self-hosted integration runtime. The self-hosted integration runtime, meaning running on my computer, I can just install it and use it to connect to services. The Azure integration runtime is called the serverless option. And obviously, as we said earlier, serverless doesn't really mean there's no server. It just means there's a server, but not under my account. Which, if we talk about it, the workload is performed to some degree on a compute that is not under our tenant. This seems like a check. We wanted from here to go on to start researching how the integration runtime works. And for that, we have the self-hosted integration runtime. Once we can install the software on our computer, which has the same logic as the serverless one, this turns it into not a black box research, meaning we have executables we can reverse engineer, understand how they work, and potentially find a bug or a vulnerability that we might be able to exploit. One thing worth mentioning about this, it can be on-premise, meaning you don't have to even install it on your cloud VM. You can install it on your computer at home. And has over 95 connectors. Installed, it looks like this. Always fun to look at pretty user interface. And we found an RC. One of these 95 connectors, actually a few, but one of them was relevant for here, had a shell injection. Meaning, if we input certain credentials, a username and a password and a port in a specific way, we can actually, instead of having the integration runtime connect to that data source, it would actually just run code on itself. Seems like a pretty cool feature. And you should note, this is an RC on the self-hosted integration runtime, which is, as the name says, self-hosted. It's not very interesting to run code on my own computer. But because we said the logic is probably the same connectors are supported, then this means probably the RC on the self-hosted integration runtime would be the same as a shared integration runtime. But what should we even try to run? We try the shell injection with who am I. We don't even know if it will work. If we run it on our computer, we would just get service permissions, like in the Windows service, right? With not very interesting permissions. But when we tried to run it on the serverless Azure solution called Azure Integration Runtime, we waited for a few seconds and we got this into our server. The IP address coming from the machine, and we are running as anti-authority system, meaning we can do pretty much anything in that Windows machine. We took this RCE, we ran it again and again and again, and we got the same IP, and we ran it from another account. And we also got the same IP address, meaning it's running on the same machine. So we started thinking to ourselves, maybe this machine is also shared between different accounts. So this machine might have the data of another customer as well. So the first thing we did, we wanted to search for the process that connects to the data sources and contains the credentials, and we took a memory dump. I would just say there were plenty and plenty of plain usernames and passwords just there for grabs. You also had API tokens and tokens into Azure. This one, obviously censored, is a token used by Microsoft. It's Microsoft company uses this token to access their internal platform. So we're running a system. We have the memory dump ability to extract passwords from that instance. And if we're going to our checklist, we talked about the bonus fact that said compute is shared between more than one tenant. I would say check. We found a file that is a client certificate that is used to being able to authorize in front of an internal management server. That internal management server has API definitions that you can just look at in the file system. And it mentions all of the APIs that you can call. And with these APIs, you can query other customers' workspaces, you can query their runtimes, and you can even do the following. You can tell a runtime, any customer's runtime, doesn't matter. You can tell it to connect to your own data source. And if we're doing a recap, we just said we found in one of the connectors in RCE, and this led us to everything. So this means we can use our shell injection, tell any runtime, hey, please connect to this server. Instead of connecting to the server, we will exploit their connector. We will run code on that runtime. We'll do it again and again until we run code on every single runtime owned by every single tenant in Azure Synapse Analytics. And then we can use our memory dump to leak plain credentials. Let's just see it in action. In this video demonstration, you can see a customer. The customer simply enters the username and a password for an HTTP server. The attacker, us, we can just access and query the Synapse workspace, find the name, and with our exploit that we wrote, we can simply run code on that machine, take a memory dump, and get plain credentials. Now the pattern applies here too. We take from our tenant and RCE, in this case it wasn't the feature, we just needed to find an exploit, into that shared integration runtime. Then, privilege escalation, what is that? We were running as system. Once we found the client certificate and we understood how the internal API works, we could just access the internal service, and with our previous exploit, we were able to go into other tenants. Either way, this research took a lot of time, and it was very complex, this one, and also the super glue that we introduced earlier. But I would want to mention that not always taking over a service, and even this pattern, has to be this complex. And I'll pass it to Yoav to show you how simple it can be sometimes. Pretty scary.
Thank you, Tzah. So, as Tzah mentioned, not everything has to be hard. Sometimes you get to see all the pattern in action with a few simple steps. And for that, we'll talk about Azure Automation. Azure Automation is a service that runs PowerShell and Python scripts for you as a managed service. They usually use to ingest data and do some sort of transformation or work according to some sort of events. For example, a timer event or some event on the system. The scripts themselves are running on a shared sandbox or a hybrid workers. And it has support for managed identities, which means that you can give the scripts permission to access Azure resources. Okay, so if we go to our qualifications, data ingestion, check, it parses data. The workload is shared to some degree, and not to some degree. They say it's a shared workers, which is great. And again, the compute is not ours, but it's also shared. So the first thing we did when we looked at this automation API service, we asked ourselves, wait, this thing has access to Azure identities. How do the Azure identities get from the service into the script? There has to be some sort of pipe that takes it from A to B. So apparently, it's like everything in the cloud, it's an HTTP server. But apparently, there is when you start your script, there is a job starting. There is a server running in the background, and which allows you, as your script, to go ahead and request your managed identities, which basically is a curl command that you ask for your managed identities. Now, I want you to really, really focus on this thing. Do you see the weird thing? I'll help you. Do you see the weird thing? Okay, so port 40,008 is a really, really strange port to have to a local server that has no problem with ports. So we Googled port 40,008, and of course, there is other usages for the ports, like the Brothers in Arms online service. But we estimated that this automation service is not probably serving the Brothers in Arms online. What we speculated, and our spidey sense was tingling, that there is probably they wanted to use the port 40,000, which is a round, nice port, but someone was already taking this port, so they had to go to the next one, and the next one, and the next one, and we got 40,008. Apparently, there were 7 other people with their port already taken. So we have decided to do a really, really complex exploit, which basically starts scanning port from port 40,000 and goes up 1,000 ports, and just tries to request from those servers the token to yourself. And we said, no way this was going to work. But to our surprise and amazement, we started getting like tokens, a lot of tokens from our machines. And these tokens were actually for other tenants that are running, that were by mistake scheduled to run on the same machine as ours. So we basically just requested other tenants' keys, and we got them, which is pretty fun. Now, one of the things that an automation service allows you to do is to automate. So we automated this exploit, running it over and over again, and just extracting from the token the tenant ID. So we will know how many different tenants we're dealing with. And we got to thousands of tenants for companies worth billions of dollars. We had like 50 of the S&P 500 companies in there. So circling back and talking again about our pattern. So from this time, we didn't need an RC, it was a feature. We didn't need a PE, it was kept. We did a request to an internal server, which basically gave us credentials to all other tenants, which is really, really, really cool. So what's the takeaways from that? Or what are we learning? First thing is shared tenancy is really fun for us researchers, but it's really tricky. It's one of those places where you try to have it both ways, share and unshare. You want to have isolation and sharing in the same time. And this makes the cloud providers' work here very, very tricky. The second thing is that you as a researcher don't want to find one bug, one issue. If you open any bug bounty program, there are millions of issues. The idea is you go ahead and you try to find patterns, because patterns lead you to find more and more instances of the issue, and that way you can basically scale your efforts and be able to be much more effective as a researcher.
One more takeaway we'd like to mention is a bit about the double-edged security being pretty much in the cloud, which means we didn't talk about patching process here at all, but we would say the cloud security teams were very professional when we reported the vulnerabilities, and most of the time they close it within days. And the good thing about the security there is once the patch was deployed, it affects everyone. Meaning no one needs to patch it manually, no one needs to install any update, it just works. The problem and the reason why it's double-edged is because once there's a vulnerability, it doesn't have to do with versions, with your firewall rules, with nothing. Once you have a vulnerability in a cloud service, it also affects everyone. So that's a problem. And we'd like to thank you very much for having us. And if you have any questions, we're here to take them.
Okay. If you have questions, great. There's a mic over there.
Microphone.
Yeah.
Hi. It seems that you finished your work in today's presentation day back into December of 2021. After these 16 months, do you find that they fixed the problem so that you cannot redo it today? My second question is, are there any other surveys? You described that as 200 surveys for these two cloud service providers. Are there any other services that you are aware that you are progressing in doing the same methodology to find out the data leak out through either the OAuth token or the data you can access from the other tenant? Thank you.
So for the first question, we found more issues, and if you go to our blog, you can find more. We only have 40 minutes, which is not a lot of time to talk about everything. The second question is whether there are particular services or cloud providers that are more affected by this issue. It's not, I say that all cloud providers are world-class, really, really, really good at what they're doing. Like within their scale and complexity, nobody, I believe in this room, can do better. Like it's really, really hard, and they're doing amazing in what they do. They're not immune, but they're doing really, really great. And if you ask me whether I would put all my company's data in the cloud or put it in a data center on-prem, the answer is really, really easy. Like on the cloud every single time. Okay, great. Thank you for having us.